bro, I'm in a meeting. I'll just have to call you back. Yeah, yeah, yeah. They are going to come from Goa because Raj is shooting in Goa, right? Raj has the X5R with him. Yes. Of course, just give me 2 minutes. Yeah, yeah, yeah. No worries. I didn't catch your name. Nilesh. I'll listen. You're Yale. You're the Yale. Putting the face to the name now. Finally. Oh, yeah. Yes, it is supposed to. I don't know if it is. Nobody's here. Yeah. I just came back. Oh, just a second. Just a second. Yeah. करण तेरे को एक फोन करा था वो लिंक आ गया
It's sorted.
आ गया थोड़ा
Okay, so send me the link.
ऑडियो नहीं हुआ है अभी ऑडियो नहीं हुआ है अभी ऑडियो नहीं आ रहा है नहीं वो तो म्यूट मैं इसको ऑन करूंगा तो फीडबैक आते रहेगा यही साउंड वो पकड़ेगा और वापस ये करेगा
भाई 5 मिनट में शुरू
इसका ये है इसका स्पीकर इन
किसका स्पीकर
इसका
ऑडियो में देखने एक बार
यही है ना इसका दोनों
दोनों इसी में से आता है
इसकी ऑडियो ऑफ कर देता था
ऑडियो
बेसिकली
ऑफ
भी
ही है
उससे ऑडियो आता है ना फिर
हाँ यहाँ से
ठीक है
हेलो आ रहा है अभी
ओके जल्दी से मेरे को ईमेल
प्रमोद
भाई माइक वाइक सब सेट है ना उसको बुला रहा हूँ
एक सेकंड रुक इतनी जल्दबाजी में आ, मैं तेरे को लिंक भेज रहा हूँ तू अपने लिंक पे पहले खोल के चेक करियो एक बार
जल्दी
करण डॉट बोला।
हाँ किसी पे भी भेज दो, वही जल्दी से सब्जेक्ट में मत डालना लिंक।
सेकंड लिंक से इसका
ठीक है।
साउंड
ठीक।
नहीं, साउंड की जरूरत नहीं है,
ये दो लिंक क्यों है?
वो नीचे वाला है, वो ऊपर का कुछ नेम शेयरिंग है ऐसे कुछ।
ये
हाँ,
साउंड
साउंड मैं समझा। हम्म?
ये इसमें क्या फायदा है? ये किसका जो बोलो मैं यहाँ कुछ भी नहीं होता, वो बोलेंगे
भाई जल्दी आ
और
जाओ,
इससे जाएगा स्पीकर पे।
आ जाओ
ये
जल्दी।
सिर्फ उनका फोटो निकाल के और स्ट्रीम करने के लिए ताकि लोग सुन सके। हाँ इसको बंद कर दिए,
भाई
ये
लिंक
show-
नहीं है।
मैंने भेजा।
हाँ एजी का सामने होगा तो लेफ्ट साइड पे ऑडिटोरियम है, बस अंदर आ जाओ। वॉशरूम एजी और ऑडिटोरियम के
नाइन
बीच में।
डॉट नाइन मीडिया के इसमें जाना। एक सेकेंड ना।
चाय चाय तो पीनी होगी।
हाँ, वो आपके लिए सर।
नहीं मैं चला जाऊंगा बाहर। ये भाई बाहर आते हैं। अच्छा मेरे लिए आई थी, मेरे को नहीं पता। कोई नहीं आप भी क्या हो गया। हुआ है ना?
हो गया।
रिकॉर्डिंग इज नॉट अवेलेबल।
इसी से हाँ, सॉरी वो लिंक गलत है।
यार उनका सेटअप भी करना है, मैं सेटअप करवा रहा हूँ ठीक है। भाई वो नहीं कर रहा है।
अरे चल रहा है, चल रहा है, वो लिंक नहीं चलेगा, मैंने गलती से दूसरा लिंक भेज
आ
दिया।
गया भाई।
ठीक है।
एक बार करण को बोलना चेक करने को।
कैमरे की लोकेशन देख रही है।
This is the final link.
No, I'm sending you the final link.
So whatever final is final. Okay, I'm calling Vijay.
Just one second. हाँ हो गया ये, वो फाइनल लिंक आ गया तुम्हें।
Who's you doing that?
हाँ वो
Nishan.
अच्छा
भाई निशान क्या चाय मार रहा
परफेक्ट
है?
हो गया।
That is the final one.
यस
I'm sending. I'm calling Vijay.
हाँ ठीक है, चलो ये एक्चुअल में
इसकी
लाइव है।
लोकेशन बताओ जरा कैसे दिखानी
हाँ
है। हमारी रिकॉर्डिंग नहीं आ रही है।
रिकॉर्डिंग नहीं है, लाइव है।
चल गया लिंक, चल गया। हेलो, लिंक चल गया। फिर वो कैमरा खोलेंगे, कैमरा खोलेंगे, सेटिंग चेक करनी पड़ेगी।
हाँ वो सेटिंग की है सेट।
ठीक है, तो
ये बीच में आ जाना चाहिए, नहीं तो आपको ये देखते रहना पड़ेगा। ठीक है,
चले।
देखते रहिए जैसे ही हो आप।
Boom, guys. Magic just setting. So we should chat about it.
Thank you for the kind introduction. Can you hear me in the back? You don't need a microphone. Great. It's a pleasure to be here. This is actually the second time I've spoken here. I don't remember when, maybe when Karen was here, I came and spoke to some of the users. Huh? Was that your? Okay. Okay. Oh, yeah, the Institute for Contemporary Studies. Yes. But it's the second time I've been here. So anyway, it's a pleasure to be here. Uh, so this is, I think, particularly. Is this? You want me to stand here? Is this good? It's pointing. You want to? There's too much technology at play here. Um, so what I'm going to do is spend the first 30 minutes or so just telling you a little bit about the work uh, that my students and I do in our labs, and also give you a sense of some of the coursework that our students take, and then perhaps talk a little bit about bringing some of this coursework to this forum, and to be shared in the Delhi area, using a combination of online education and lectures like this, where we can get educators from the United States to come and spend time here. So that's the evening's agenda. So let me first start by telling you a little bit about the field. I assume you're all here because you know a little bit about aerial robots, about drones. Some of you may know more than others. But let me just tell you where things started. Um, don't know why this is. Ah, there we go. Come on. Let me just start by telling you a little bit about. You need the mic. Yeah, yeah. For the people online, I can put this on. It's okay. I can turn this on. Now no one can fall asleep. So again, going back a little bit in history, if you look at the exponential growth of this industry going back to 1980, when there were hardly any unmanned aerial vehicles. And of course, the thing to note is that on the y-axis, this is a logarithmic curve. So essentially, it's been growing exponentially. And this was the story in 2010. And around halfway through the last decade, we started working with small aerial robots indoors using a motion capture camera system, as you can see in this picture. So this was around 2006, 2007, 2008. Of course, there were similar developments outdoors. And to me, the most impressive outdoor development was the development of the X-47B. This is by Northrop Grumman, where they actually showed that an unmanned aerial vehicle could be commanded remotely to land on a moving ship deck in the high seas in a very short runway. So this was in 2013. But if you fast forward to 2015, what really happened is that aerial robots, unmanned aerial vehicles, took the world by storm, and they left laboratories, they left outdoor arenas like aircraft carriers, and entered your homes, as you can see in these popular magazines. And it went well beyond what you see in your homes to real commercial applications. So in 2015, they predicted a $15 billion industry projected to go to $25 billion by 2020. I think it's already well past that. But again, the excitement to me is that you can actually think about applications to agriculture, to infrastructure protection, inspection, mapping, and all kinds of interesting things. So really a burgeoning industry. And I think we're just getting started. So there's a picture I like to show that the field is only in its initial stage. For us, some of the challenges are having to do with predicting the direction of the field and then trying to keep pace with industry and be one step ahead of industry. In my lab, we think about 5 directions in which to push research. If those of you who are familiar with robotics might have heard the 4 words starting with the letter D. So robots were used for dull, dangerous, dumb, and dirty tasks. So playing off of that, we use 5 words that start with the letter S. So first, we think about making robots smaller so that they can navigate indoors in more complex environments. We try to make them safe. Of course, make them smart so that they can recognize the environment and they're able to essentially reason about complex environments. We're interested in speed, and the reason we're interested in speed is not just because we want to move quickly, but also because we want the robots to react very quickly to changes in the environment. Many of you may have read about the accident that Tesla had. And the reason it had that accident was because the vehicle could not react fast enough. Most often, if you build autonomous systems, you have to think about designing efficient perception action loops. Perception meaning you sense the environment and then you take action. Well, if those loops don't operate fast enough, then if there are errors in the loop, you don't have time to recover from the errors. And that's what led to the crash. So speed can also mean that as things are changing around you, you're able to detect changes and you're able to react to those changes in a fast and efficient way. And then finally, we think about swarms, large collections of vehicles operating autonomously. Today, we all talk about the Internet of Things, where things are mostly static objects. They're sensors, perhaps Apple Watches that people wear. When we think of things, we're thinking of aerial robots, which are networked in the same way machines are networked on the internet. So our applications are to search and rescue. We want to be able to operate in environments like this. This is after the recent earthquake in the Himalayas. We operate in environments like this where our robots navigate apple orchards, counting apples and detecting pathological conditions. We operate outdoors using swarms for security and first response. And then we operate indoors in environments like this for logistics and mapping assets in indoor warehouse-like environments. So let me just go through the 5S words. We'll start with the small size. And I'll tell you the smallest vehicle we've built. And this is about, as you can see from the size of the palm, it's about 11 centimeters tip to tip, weighs about 20 grams, and consumes only 6.5 watts of power. And yet it can travel at speeds of 6 meters per second. And if you make it small, then you also make it safe. If you build large vehicles, then the chances of getting injured by rotating blades at high speeds is pretty high. You make it small and they're automatically safer. With the small size, you also can make them maneuverable, as you can see in this video of honeybees, which has been slowed down by a factor of 20. So you see these honeybees are able to collide with the environment, recover from the collisions, and then navigate to whatever it is that they're doing. And you can also see them bumping into their neighbors. So because when you reduce the size, you also reduce the inertia, the momentum that is transferred during these collisions is small and manageable. And as you can see in this video, you can see collisions occurring frequently, and the colony of bees does just fine. So in our robots, we do the same thing, and I'll show you 2 videos. The vehicle at the top is a 500-gram vehicle. The vehicle at the bottom is a 25-gram vehicle, and you can essentially show that the maneuverability goes as 1/4 the length, the characteristic length of the vehicle. Also, the robustness, we do experiments with California water shortage is a big problem. And unless we do it early in the morning, you're not going to get the information that the farmer needs to determine what sprinklers to turn on. So that's another area where we almost have to use drones. Question the back. Here.
Is there so the way it's moving, how is it that the fans are not colliding and the fans are robust? Are you measuring from rotation to rotor blades are created? There's a number of videos where you can see the collision is happening at the end of the branch on which the rotor is kept. So what if there's a collision on the fan blade and the fan blade goes off?
Right. So the reason we have the cage is to avoid collision with the blade itself. So what will happen is if the blade actually breaks, then the vehicle will come down. But again, large swarms, we want to be robust to failures of individuals. But just to make life easy for us, we just put those blades in place. Actually, even the propellers don't break if they come into contact with the environment. What really bothers us is, what really spoils the performance is these blades actually get entangled with each other. So it's a problem. 2 neighboring sets of aircraft entangled. Yes.
You said like you use off-the-shelf components in some of the tools. You also open source the code and on these.
Yes, so many of the things that we do are open source. They're GitHub repositories. Most of the times, the students who work on this are lazy and they don't want to open source it because then they'll get bombarded with questions, and that's the reason they don't. But pretty much everything we do is published, although we do have a couple of spin-off companies that we license software to and others. I'm told I have time for one more question. Yes.
What are the chances of cross-filtering in corridors to increase the manual?
I'm sorry.
What are the chances of having cross-filtering?
Right, trust me, absolutely. So again, this goes back to the question of why have you changed your design the last 5 years? There are lots of interesting ideas. In fact, I have a group right now that's working on a 7-rotor aircraft, which is unidirectional. In other words, it can roll, pitch, and yaw, or go sideways in any direction you want. And it turns out if the propellers only spin in one direction, you need at least 7. So they're working on that. You could certainly cross-vector the things. But as an engineer, you want to make things as simple as possible and no more complicated. And I believe, again, going back to the question that was asked, this basic design that became popular, and by the way, I can show you examples of these designs that we tried in 2000. Our first experiments was with a spring with a sea of balloons that were attached to the bottom, so if it fell down, nothing would break. But that design has survived over the years and has proved to be the simplest design with small scale. Got one more question? Okay. So artificial intelligence is a loose term that's used to describe algorithmic advances in autonomy in this particular setting. So the old-fashioned way of thinking about this is that you have what we're called expert systems, rule-based systems for doing a variety of things. So that we actually use. All our scripting languages has that flavor. The newer, more exciting part of AI really comes from the fact that you can use statistical machine learning techniques to deduce information. We do that, but not in mission critical cases. So I'll give you a great example. If you use computer vision to detect people in the room, so let's say I have the world's best face recognition algorithm, and I mount it here. Right? How many faces do you think it'll pick up? 100%? 95%? 90%? So probably somewhere between 90 and 95%. Right? Now imagine those spaces, each of those spaces were mission critical. They're not, but I'm just making that up. Well, 95% is not good enough. So the use of statistical machine learning techniques to get to 99.9999%, we're not yet there. Of course, experts will tell you, give me enough data and I'll make it that much accurate. Well, to give that much data requires exponentially more data collection and exponentially more storage and exponentially more computing, which is all possible, but it's not there today. And that's why all the things I showed you, we've not used machine learning techniques. However, for detecting fruit, so we do experiments with oranges, apples, and mangoes. We actually work with a farmer in Bangalore. We also use machine learning techniques for tracking and detecting fruits, for tracking and detecting diseases. So those are not mission critical applications. Everything I showed you is sort of mission critical. All right, well, thank you very much. We should move to the next part. Okay. Yeah, that's fine. So I want to just share with you this program that I've been working with Kumar, which is essentially trying to bring some of this through a blended learning program. So it's a collaboration between our school, and engineering, and 9.9. So it's essentially what we teach on the campus, but we're putting all of this online. Much of it is through Coursera, although we also have a partnership with edX. And then parts that are offline, which is our face-to-face, and that's where the blending comes in. It could be essentially instructors that might travel from the US to here, but more importantly, I think, build on local talent, local expertise, and also local needs in local industry. So that's the second piece. So we're starting with aerial robotics, the material that I just talked to you about, as a pilot, and eventually move to something which is more oriented towards software development. So this starts with software essentials, data science, and then software engineering skills. So unlike other programs that basically teach you just the skills, to me, it's important that we teach the fundamentals that allow you to learn not only the skills that we teach, but new skills that we don't know will be needed in the next 5 years. Right? So that's the big difference the kinds of courses we teach. So again, the robotics course is a pilot. We really want to start thinking about things that are going to be needed by Indian industry beyond robotics. So we're the only program now that's a certificate program in aerial robotics. We're seeking to be number one. But just an overview, I think what we want to do is start with mechanics of flight, design, dynamic models, controllers, planners, and also what is not reflected here is computer vision techniques for state estimation for flight. I think a lot of what you see in industry is based on GPS-based navigation, and what we want to do is to get away from GPS to the GPS-denied navigation. And then really think about how to support the rapidly growing drone industry in India, which is really where the face-to-face interaction with local experts comes in. So a few of the highlights. So this is supposed to be a kickoff, which is a classroom lecture. But we'll have coursework online with training, some experience learned workshops, and once we get a certificate, and then connection with industry. So that's the whole idea of this class. That's me, you know me. And so why would you apply? So again, as I said before, the next 5 years we'll see lots of disruptions. So, and I could give you my favorite sources of disruption, but whatever my source of disruption is, technology is at the core. And so to me, robotics technology is an important part of things that are going to disrupt our lives. So that's why you want to learn this, and so we take our curriculum to constantly change this, try to bring it online, and focus on emerging technologies. So this is really why I think a certificate like this makes sense. So Kumar is the best person to answer some of the questions about logistics. We're going to kick this up in January. Do you want to jump in?
Taking off from where the program is going to start in the first weekend of January. It's going to be kicked off by a classroom lecture by Kumar. It's going to go on for about 4 weeks. So just imagine doing an online program on Coursera where you have a self-paced library over 4 weeks. You're part of an online private cohort, unlike how it is on Coursera currently when you're part of a global cohort. So for the people who will be part of this program, will have a private cohort on Coursera. And over each weekend, there will be some sort of industry engagement, either locally or virtually through people from University of Pennsylvania over each weekend. And at the end of it, you will receive a graduation certificate in area of robotics. So that's just the fundamental. And it's going to be about 4 to 6 hours per week, 4 to 6 hours per week of commitment, and about 2 to 4 hours over each weekend. And the application process is going to be rolled out in the next couple of days. The website for this is going to be live by tomorrow, so we share the link with you, and you just need to register your interest in something like this, and we can get in touch with you. The classroom is going to be a location in New Delhi. It is most likely going to be this place where the first lecture will be by me. And that's pretty much the logistics aspect. Yes. So do not visit this place, this website. Please visit it tomorrow. It will be live tomorrow. So that's basically.
Okay, good. Thank you very much. Question.
When you say it sounds like would it go to the day or
You pick it.
It's
You determine what time works for you. Who should do this course? The course is designed so that in the first week anybody can take it, but as you work your way through the course, it becomes progressively harder. Who should take it? I think people who really want to do R&D and deployment in the field of aerial robotics. bachelor's degree. I think it works best when you have a bachelor's degree in some science, technology, engineering, or mathematics-based field. But the first week, you can take even if you have a history background. We have high school students who have completed the first course for first week.
Will it be hands-on? Should they see any notes or get an idea about how we can make those?
So there's a hands-on component which is primarily based on writing software with a simulator. But there's also a face-to-face component with coaches here. Perhaps you could say more about this.
So we are planning to get over each of the remaining 3 weekends a couple of industry experts who will contextualize the learning that you get from the academic curriculum with respect to the local Indian industry. Something which is quite interesting is an experiential learning workshop by Quidditch Drone Academy. Quidditch is a recent startup and one of the key industry drivers in one of the key drone industry companies in India these days. So we are going to have them come in and do some hands-on work. It will be a 1.5-day workshop. And in fact, you should say hi to me probably after the talk. He is a core team member at Quidditch, and yeah, so they will be doing that. That will be probably on the second or third weekend. So
I have an education robotics and finding the
let's talk. And also, we will have a local teaching assistant or a coach, if you will, who will help you problem solve and understand the technical aspects as well as the industry aspects. So there will be someone else on board like that.
So there are no questions. So if there are no questions, thank you very much. Thank you for coming. And look forward to seeing you in one of the classes soon. Thank you.
I just want to take a second to thank Dean Kumar for being here all the way from Philadelphia amongst us and for actually coming up with this amazing idea to do something like this for people in India. I think it has great potential and we hope that some of you apply this program and we'll be in touch with other programs as well. But thank you so much for coming. I know this was short notice and just thank you. I think it's
That's really good. You don't
తిరగదు సార్ బయటికి కరెక్ట్ సార్ స్కూల్లో పెడితే
Yeah, 20 seconds to give us selfie if you want. And someone please take on next. All on next. That's what I see. And you then move faster.